What's up everybody, this is Cakez and welcome back to our first tutorial in which we set up our C++ project. The first thing we need is Git, and we are going to use it to create a project and then save the changes. You can download it from this website right here. I'll put the link in the description if you want to. Alternatively, you could also Google Git, should be the first result. During the installation, I just leave everything on default. If you want, you can change anything, but you should know what you're doing. Once we are done with that, I want you to open up an Explorer and then click in the top bar to search. And inside the top bar, please type in CMD and then hit enter. This will bring up a terminal window in which we type in Git. And that should give you a long message like this. It's basically telling you that Git is installed and it knows the command. The next step is to open up GitHub or whatever Git service you use, and then on the side create a repository of your liking. I will call the project Celeste clone, and of course it will be public. And then for the gitignore, I'm going to create that later. You can, if you want to, add a default gitignore for your needs. And then of course we create the repository. The next step is a little bit more complicated, but I'm going to include it in case you have never done it before. You need to set up an SSH key for GitHub if you want to clone repositories and push to them. In order to generate an SSH key, you need to type in either the SSH keygen using a certain algorithm, and then if you want to, you can connect it to your email address that you use to connect to the website. In the past, I've used the RSA key generation because I already have a key. If you want to, you can use either of these. It looks like that one is an old one, the RSA, and that one is the new one, the ED25519. So you're just going to copy and then paste this into a terminal window and then press enter and follow the instructions. I'm not going to do that because I don't want to create another key. And then once you are done with that, you need to copy the contents of the public key. You can find it by going to your PC, the local C drive, users, then your username, and then under the .ssh folder. This is where you find your public key. You can open it and then copy the entire content of it. And then once you're done with that on GitHub, go to your settings, SSH and GPG keys. And then over here, you can add a new SSH key or a new GPG key. Once you're done with that, you need to go back to your repository, click the green button for the code, and then select the SSH option and copy it. After that, go back to the terminal window and type in git clone and then paste the message from the clipboard and hit enter. This will copy everything from the repository to your local machine into the folder called whatever you named the repository after. For me, it will be Celeste clone. And then when we open it, we should only have a .git folder, which is usually hidden, and a readme file. Next, please create a new file and call it build.sh. This file is going to act as our build script. That means we are not going to be using any of the known build systems like premake, makefiles or cmake. The reason why we are using an sh file here is because it is natively supported on Linux and on Mac. On Windows, since we installed Git, we actually have an sh executable that you can locate on your C drive under Git. On my machine it is under C, program files, Git and then bin. And there we have the sh executable. This allows us to invoke shell scripts, which effectively means we can now invoke the script on Mac, Linux and Windows. And so I wanted to give that a try to see how it works, because we need to use Git anyways. I know that this is a little bit weird, but in my opinion it is better because we can use the clang commands directly and we have a list of things that actually happens on each operating system separately, and we will get to that at a later stage. But I just wanted to explain why we are using this instead of not cmake. I hate cmake, okay? So yeah, once you have located the sh file, please make sure that you add it to your environment variables by typing in environment variables in your search bar, and then please add in a new entry containing the path to the sh file. Now you should be able to invoke the build.sh file. Next, we need to download a C++ compiler, and we are going to be using llvm because in this tutorial we will focus on Linux and Windows. And then another person is currently actively developing on Mac, but I'm not going to cover that until it's done. In the list of download options, and I will again put the link in the description, please select the version llvm 16 Windows 64 executable. Once that is done downloading, please make sure that you select for all users and then hit next twice, and then it should start installing. If we go ahead and open up a terminal now, we need to make sure that the old terminal is closed and we open up a new one. Please make sure that you do that because llvm adds to the path. And if you have an old console window open, then it won't know about that until you close and open it again. That's a Windows thing. Don't ask me why that is, but you have to do it. Otherwise, you will not find the clang command. And then, of course, we type in clang, which should give us an error message. No input files. Great, so now that we have the compiler, we have Git. Next, we need an IDE to program in. And among all the options, I think Visual Studio Code is the best. Not only, in my opinion, is it the most performant, but we also have the capability to cater it or change it to our needs. Downloading Visual Studio Code should be quite simple. I again put the link in the description, but just type in Visual Studio Code into Google and you should find it. The installation instructions should also be simple. The default ones always work. If you want, add any special ones that you need. And then once that is done, please open it up. First, we are going to install some extensions. I use the C++ extension, and then for me, I always download Vim. And then lastly, I also add in the shader language support. I know that Vim collides with the shader language support for Visual Studio Code, so whenever you open up a shader for the first time, it lags. But you get used to that and it's fine. I just wanted to point that out, that if you experience any lags opening up a shader file for the first time, this is the reason. Okay, and now that we are done, please create a new folder called .vscode, and then inside that folder, create a new file called tasks.json. I'm going to quickly show what I'm typing in here, because that is not so important. We are basically creating a task that invokes our sh build.sh file. And this will work on Linux as well as on Windows. Again, no comment on Mac. I've not tried it myself, but I have heard that it works like this as well. After that, we can finally start and program. So create a source folder, and then inside the folder create a main.c++ file. We start by typing in a simple int main function together with a while loop that conditions on running, and then we are going to put a generic comment updating the game, for example, and of course after the while loop we return 0. On top we add in a static bool running and set it to true, and that is basically the simplest version of an update loop in a game engine. And then finally switch to the build.sh file, and inside of that the only thing we need to type in is the ! bin bash followed by a clang source main cpp, and we want to output it to schnitzel.executable. I chose schnitzel because on stream we actually created a schnitzel engine, and so it is kinda a weird name. You should maybe call it Celeste or something else. This was not my decision, okay? And then lastly we need to tell Visual Studio Code how to run our program, and for that we create a new file under the Visual Studio Code folder calling it launch.json. Again, I'm not going to go into too much detail here, but basically we are setting up a C++ Visual Studio debug type, and then we are invoking our schnitzel.executable. Now we can hit F5, which will run our program, and obviously nothing happens because we are not updating or we are not doing any calculations in the while loop. And this is going to be our build system from now on. We're going to add to the build.sh file over time. It will not be that big, but we will be able to support Windows, Linux and Mac. And if you want, you can now type in any code and try to compile it and then run the program. You know, for example, you can printf something to the console. Now that we are done with this, you should have something that looks like this. And if you see these green indications here that show that this is something new to Git. And if we were to push right now, we would also push the executable and other files that we create in the future that we might not want to have in the repository on Git, because we want to create them using the build script. For example, if we add in the -g or the -g here, and then we build again, we get an ILK and PDB file. And so I have a gitignore here that looks something like this, and we are just going to copy and paste the contents of it into the repository. So we are going to ignore any executables, any ILK files, zip files, exp files, obj files, DLL files. The vscode folder, if you don't want that, put it in here. I'm just gonna keep it. And this is from Visual Studio Code. I don't like this file. Sometimes it gets auto-generated from the Visual Studio Code C++ extension. All of these we copy and we create a new file, gitignore. And then we paste that in here. Now we only have our build file, the vscode folder, and the source folder. Now we can actually push to Git. I quickly wanted to add that because in the original video I didn't have that. Thank you for watching this tutorial. I hope you enjoyed it. I hope you learned something, and I'll see you in the next one when we create a Windows window. Until then, have a good day. Peace.